Okay guys, this is going to be a little bit of a departure from my regular videos. I have a dead guitar amplifier, so what I did to solve that problem is I went out and I got me another dead guitar amplifier. Kind of weird reasoning and all that stuff, but enjoy fixing things, and I saw some potential in this old amplifier. I was told that it lights up, but it doesn't have any sound. Okay, so this is a ValveKing 100 head, and it is the second model that they made, so ValveKing II if you want. They have a lot of features on these things. They've really made it kind of an all-around amp with a lot of things like different wattage settings on it, it's multiple speaker arrangement settings, the multiple speaker outlets. It's got output jacks for XLR back here and also for USB, return switches, reverb switch, there's a boost switch, so you can control a lot of things from it. But for the recording parts of it, it has this little switch right here to cut the speaker out, and it looks like somebody bumped that thing and broke the guts out of this little switch. So what I'm going to do is pull this thing apart and see if that switch is repairable. It's at least replaceable, and that might be all as necessary to get this thing back up and running. I need to get the chassis out of this case, and never worked on one of these before, but it looks to be pretty much a typical straightforward setup. You notice there's a couple of screws on a flange down at the bottom of the chassis here. So I'm pretty sure those have to come out. And since I didn't have the back cover off before, it does in fact have the serial number and model number in here, and it does say that it's a ValveKing II head, showing as a 120 US. And this one was manufactured in April of 2015. Okay, and then there are 4 screws on the bottom of the cabinet here, which I assume are the actual chassis screws. Okay, I'm not some kind of amplifier technician. I just have a pretty strong background in electronics, and I got my schooling back in the day of when they were kind of switching over to semiconductors, but tube stuff was pretty prevalent, and of course the tube amplifiers have never really died off. Okay, so it's not real lightweight, but it is. It's not quite as heavy as I thought it was. It has some pretty good sized power and output transformers on it, and I'm gonna have to figure out something to set it on or to remove the output tubes before setting it down so that don't crush those. It has four 6L6 GC output tubes on it, or EL34. The preamp is a couple of 12AX7 tubes, and then it looks like they've probably got another phase inverter over here. Okay, so here's that broken switch. You can just see the handle on it just flops around. And it's attached to this breakout board on the back. After pulling out all the screws from the face down here and the nuts on the jacks and switch, this breakout board comes out. That's some reasonably decent access. Yeah, typically there's a tail on the end of this handle, and this one feels like it's possibly broken off, but not really anything you can get at with it in circuit like this. Okay, it's several weeks later and we're going to get back to repairing this amplifier. Don't know what Peavey's problem is, but I finally got a part ordered from them. For some reason the parts department's like it's got one person that answers or has a phone, and they don't return their voicemail. It's pretty frustrating. After waiting for them to return a call, it didn't happen. Finally managed to find somebody that answered the phone and coerced them into placing an order for me, and then it of course took a few weeks later for this thing to show up. So we'll get the thing stuck in here and see if we can make this thing work again. This board's in kind of a difficult position, and with all the wires attached to it, I don't really want to disconnect all that to work on it, so I'm going to try to fix it in place. So it's got a lot of plugs in the back of it. We'll just stick a guitar cable into it to hold it up. Okay, this is going to be lead-free solder, so I'm going to go ahead and hit it with some flux first, and then I'll put some more solder on top of it to kind of alloy it, soften it up. Okay, I'm going to try to use this solder removal tool on here, or solder sucker, and vacuum will pull the solder off theoretically. Sometimes these things work, sometimes they don't. Okay, finally got that thing out. Okay, there's the new switch.
go through here and clean all this splash solder off and make sure we haven't created any shorts anywhere. Another thing I need to do is take some alcohol and clean off the flux that I used on here.
Go ahead and clean out these tube sockets while we're in the neighborhood. Pins are a little mangled up. A little rust showing up on that transformer, so I'm just going to go ahead and take care of that right now. This isn't a cosmetic thing. Corrosion on a transformer can cause failures down the road that can be really hard to figure out, so it's just well to stop it creeping in there while I can. Okay, I have a dim bulb tester that I made and also a variac, so I ran the amplifier up on that power supply just to check things out after putting the tubes in. These 12X7s are all hooked together in a series parallel setup, and just a search on the board I found this R22, which happens to be in line with the tube heaters, has obviously blown the lead off right here. I checked the tubes prior to putting them back in for resistance, and they all seem to be okay. Couldn't find any shorts in anything. One of them has a different date code on it, but I'm not quite sure how to read the date code on these tubes, but there's a possibility it's been changed out, so maybe some troubleshooting was done. The tubes have been moved, but this definitely has to go. There's a couple of different power circuits in this amplifier, and it's probably kind of hard to see because this thing prints out really tiny because it's such a large print, but right here in this section is the three 12X7 tubes, and here's that R22 resistor. So anyway, I'm going to go ahead and pull this board out and replace the resistor like it would naturally be in here. Most techs would go ahead and cut the leads off with the resistor and just solder it onto the existing leads, but I just want a neater installation. Okay, here I got the main board pulled out. I removed the shields around these sockets. Didn't need to do that, but these output tubes, those do have to be unscrewed from the top of the chassis in order to get those to come out. I had to remove the breakout board from the back again because I needed the room to slide the main board back and get it out of here. So I've got a clip on this lead for that R22, that resistor that burned out, so I'm just going to go ahead and remove those leads out of there and put the replacement resistor in. Good day to be doing this kind of work. There's not much to do outside. R22 is a 4.7 ohm resistor, and it's the one in line with the heaters. So there's a replacement, and we'll flip this over and get it soldered on the other side. Now I'll just go over this board and make sure there isn't any odd looking spots on it that need touching up with solder as long as I got it open. Got some smuts on here that I'm going to clean off and remove any of the little lead BBs and things that collect on this stuff. Okay, now we'll just wrestle this thing back down inside of here. Here's what I use to start up an amplifier after I've done the repair work on it. It allows me to dial up the voltage slowly on it so I can watch for any kind of amp spikes and other problems before it gets bad. Looks like I skipped over the dim bulb tester in this video. It has a plug that you can put into the wall or a variac, and then there's a switch that you can turn it on and off with, and it just goes series through the light bulb and out the socket. So whatever you attach to this has to go through the light bulb first. You can use that to basically put a load of some sort on a circuit so it doesn't just, if you have a short in it, just doesn't immediately kick your breaker off. There are whole videos on building these things on YouTube, so I'm going to suggest that if you want to know more about it, you should look at some of those videos because it's a fairly large subject and not in the scope of this repair video. Okay, I switched on the light bulb here, so now we have a complete circuit. Turn on the amplifier, and then I'll dial up the variac, and I don't know how accurate the voltage is on it. I'm not measuring anything here, but we'll turn it up until we start to see that light bulb I see the filament in here start to glow on it. There you can see it starting to glow. If the amplifier has a short in it, that light bulb would glow very brightly. And as I crank it all the way up, right now what it's indicating here is just that the filaments in each one of these tubes is being heated, and you can even see it in the small tubes, but sometimes in these 12AX7s the filaments are hidden, so you can't see anything inside of them, but that replacing that resistor has fixed the heater issue there. And then as I switch to standby on, this bulb should come up quite a bit more as it's applying power to everything. So now we successfully have all the filaments going. The amplifier is off of standby. What's interesting about the ValveKing II is that it has these indicator LEDs up here that shows you the status of your output tubes, and if one of them should fail, it'll go to the red. Since we're on standby right now, they're all red. And as we switch it on, you can see the outer set of tubes, the two out here, have turned green, which shows that they're operational. And should one of them fail, it would turn red. And the amplifier has various outputs on it with a 5, 25, and 100 watt output. Okay, so we moved the ValveKing chassis up here and put it onto a large speaker cabinet. I was afraid I was going to blow up the little one. And we're going to turn this thing on and see if it is going to function. Okay, that was with the switch on the back set to 5 watts. Okay, and this is the 25 watt setting. Okay, one last thing to try is to put this into the 100 watt setting. We finally got all 4 tubes indicated. And that thing is really loud. Okay, so overall this thing sounded pretty good. I don't think these tubes have ever been replaced, so it would probably really benefit from replacement in the output tubes, and it would definitely do well to replace these preamp tubes. But otherwise it sounds pretty good, and it's definitely a loud amplifier. It's amazing how small these transformers are for the output that it can accomplish, but it does manage to work. And so thanks for watching, thanks for following along.